Good day everybody. Today we will learn how to calculate pipe wall thickness using ASME B31.3. In this video presentation we will cover the following points. Means first is introduction, then why is pipe thickness calculation required, what is the need for pipe thickness calculation. Next, important points for pipe thickness calculations, means few points that engineers or designers who are performing pipe thickness calculation they should know those points. Next, steps for pipe thickness calculation with example. We will take an example and explain the steps how to calculate this pipe thickness calculation. Next, parameters affecting the pipe thickness calculation. So what are the factors that affect the pipe thickness of a pipe? And finally, assumptions for pipe thickness calculations, means the assumptions that has been made for using the code equation for pipe thickness calculation. Now, introduction. Pipe thickness calculation is a very important activity for piping engineer. Normally, for every new project, these calculations are required to be made, and these are usually submitted to the client as a report. This also ensures that for the specified design pressure, the pipe is stable to withstand that pressure. Pipe thickness calculation for process piping is performed using the clause 304.1.2 of ASME B31.3. ASME B31.3 is the Bible for process piping, and this code provides in its clause 304.1.2 the equations for pipe thickness calculation. Next, with increase in pipe thickness, the weight of pipe increases, which in turn increases this cost. So, if pipe thickness is increased, the weight of the pipe will increase, which in turn will increase the cost of the pipe because pipes are sold based on weight. Now, why to calculate pipe thickness? Why it is required to calculate the pipe thickness? The minimum required pipe thickness should be calculated to confirm or to ensure that the selected pipe will be able to withstand the pressure at the design temperature without failure. Means through the pipe there will be some fluid which will be exerting internal pressures on the piping system. So by calculating this pipe thickness, we will ensure that the pipe will not burst or fail when it is carrying that fluid. And second is to avoid being over conservative and thus optimize cost. So without calculation, we can simply easily can select a higher thickness pipe, but that will be conservative and it will increase our costs. So for optimization of cost also, we need to perform pipe thickness calculation to check that we are just selecting only the required pipe thickness, not more thickness. Now, important points for pipe thickness calculation. Now, before starting the pipe thickness calculation, one must know few of the points. These are mentioned here. First is that process plants are usually designed for 20 years or 7200 cycles. Now, this 7200 cycles, how it comes? It is considered that one cycle per day, and for 20 years means 20 into 360, 7200 cycles. Usually, the number of days for this calculation is considered as 360 days, not 365 days. Next, the corrosion allowance of pipe material is decided by the process department based on the fluid it is carrying. Usually for carbon steel, low alloy steel or low temperature carbon steel, it is taken as 3 millimeter, and for stainless steel pipes it is 0 millimeter. However, these values need to be confirmed from the process department or process team because it varies depending on the fluid it is carrying. Next, pipe material is decided by the piping material engineer, as per the fluid and design conditions. Next, line size, that will be mentioned in line list as well as pin ID, and pressure and temperature of that fluid service also will be mentioned in the line list prepared by process team. Now, mill tolerance for the seamless pipe is considered as 12.5%, and for welded or pipes it is 0.3 mm. These values are also mentioned in the specific standard of the material, means A103 STM standards. Now we will learn the steps for pipe thickness calculation with an example. We are taking the following example for learning the steps of pipe thickness calculation. That this is a carbon steel A106B5 that is subjected to a pressure of 1200 psig. It has a size of 4 inch and a design temperature of 500 degree Fahrenheit. The corrosion allowance given is 3 mm and mill tolerance is 12.5%. So it is a seamless pipe. Now the equation that ASME B31.3 provides us for this pipe thickness calculation is given by this, that T is equal to PD by 2 into ACW plus PY. So to calculate this minimum required thickness T, we have to know all these parameters. Now we will learn in next slides how we can understand or from where to take the values of these parameters. So first is the P. P is the internal design pressure. In the problem statement itself, it was given as 1200 psig. So we got our P. Next is the D. D is the outside diameter of pipe. For 4-inch pipe, it is 114.3 mm. Now from where we will get this value? This is obtained from the piping standard ASME B36.10 M, or for stainless steel it will be ASME B36.19 M. Part of the standard is produced here, that for 4-inch the inch thickness is 4.5 mm, or in millimeter it is 114.3 mm. So this is given in this table. So we will be considering 114.3 for as our D. So P, D both are finished. Now we have to get to the value of S. What is S? S is the allowable stress for the pipe material. For our case, material is A106B at 500 degrees centigrade degree Fahrenheit temperature, as our design temperature is 500 degree Fahrenheit. From where we will get the value of this S? It is obtained from table A1 or table A1M of ASME B31.3. Now, if you follow the table, that this is the for 500 degree Fahrenheit and this is A106 grade B material. Now where it is matching, this is 19.0, this is in KSI, so 19,000 psi. So the value of S also we got. Now E is the quality factor that is obtained from table A1A or table A1B of ASME B31.3. Here from this table that I have attached here, you can find that for A106 seamless pipe, the value of E is 1. So we can consider E as 1. Now W. W is the weld joint strength reduction factor. This is also available in the code ASME B31.3. From the table 302.3.5 of the code, you can find that for carbon steel material up to a temperature of 593 degree centigrade, all the values are 1. So we can consider W is equal to 1 in our calculation. Now the value of Y. This is the last value. So values of coefficient from table 304.1.1 of ASME B31.3. If you go to this value, that for a thickness less than d by c, the values of y for ferritic steel is given as 0.4. So we will consider 0.4 as the value of y. Now, if we put all the values that we discussed earlier in the equation, we will get this T. So T is equal to 1200 into 114.3 into by 2 into 19,000 into 1 into 1 plus 1200 into 0.4. So this gives a value of 3.52 mm. So this is the required thickness only for the pressure consideration. Now we have the corrosion allowance, so we have to add that value to get the required thickness for pressure as well as corrosion allowance. So Tc is equal to T plus C, so 3.52 plus 3 is equal to 6.52 mm. Now we know that it is a seamless pipe having 12.5% mil tolerance, so we have to consider this allowance as well. So Tm is equal to Tc by 0.875, which gives a value of 7.45 mm. So our calculated minimum required thickness is Tm is equal to 7.45 mm. Now in the next step, we have to go to the ASME B36.10 M table for 4-inch size, and we have to choose the next available thickness from the standard, because for this thickness pipe may not be manufactured, as pipes are normally standard pipes. So we have to go to this table that is produced here, that for 4-inch the wall thickness is given as 7.14, but our calculator is 7.45. So we have to go to the next higher schedule. So we have to consider this value of 8.56 mm, that is for schedule number 80. So from this table, the ordering pipe thickness will be 8.56 mm or schedule 80. So using 8.56 mm, we are getting a extra thickness of 1.11 mm. Now this extra thickness is important. Why? Because it helps to minimize the pipe deflection and that reduce number of supports. It adds life to the pipe beyond its design life, and also it increases the pressure carrying capability. So extra thickness is good, but not over conservative extra thickness. So that will increase the cost. Now, what are the parameters that affect this pipe thickness calculation? There are various parameters that affect this pipe thickness calculation. The main important ones are the design pressure, internal design pressure. This is the main important thing, because we are calculating the pipe thickness to withstand this design pressure. With increase in piping design pressure, the thickness also increases and the rigidity of the system increases. Now, design temperature. With increase in design temperature, the allowable stress value S will reduce. So a reduction in stress allowable value means it will again increase the pipe thickness. And pipe outer diameter. For the same design pressure, if pipe outer diameter is more, then calculated thickness also will be more. So these three are the main parameters that affect the pipe thickness calculation. Now, for calculation of pipe thickness, we made some assumptions. Actually, code says to consider some assumptions. So what are those assumptions? The first is that pipe is a thin cylinder and its thickness is less than d by 6, because for thick cylinder the considerations will be different. There is another assumption, that is P, means pressure by stress into E, that factor is less than 0.385. And the third assumption is that pipe is under internal pressure only, no external pressure. Hope it clarifies your doubts, and now you are in a position to calculate pipe thickness for your system. Still, if you need further reference or want to know more details about the pipe thickness calculation, kindly visit this link, that https whatispiping.com, where pipe thickness calculation per ASME B31.3. This is more detailed one. So that's all for now. Thank you for your time. Now, if you find this video useful, then kind of request to subscribe my channel. So subscribe and click on the bell icon so that you never miss any video whenever we publish. Thank you.